Welcome back to the Deep Dive, where we deliver the crucial, curated knowledge you need, shortcutting the mountain of documentation that surrounds modern technology. If you need to be well-informed, fast, and accurately, you are in the right place. Today, we are tackling a foundational text for anyone operating in the cloud, the Azure Well-Architected Framework, or WAF.
Yep.
If you're building or improving technology workloads, you know this document set is, well, it's absolutely massive.
It's huge, and it can be very intimidating.
It's dense, it's broad, and honestly, trying to read it cover to cover is a recipe for analysis paralysis.
You'd never get started.
Our mission today is to filter this framework for you. We're going to extract the core philosophy, show you the clear, actionable structure, and ensure you walk away not just knowing what the way is, but how to immediately apply its strategic insights to make informed, high-quality architectural decisions.
Turning that mountain to a map.
Exactly. We're turning a 500-page manual into a strategic checklist.
And I think we have to start by framing the WAF correctly. It's not just a set of standards or rules.
Right. It's not a compliance document you just have to check boxes on.
No, and that difference is vital. It's a design framework. It acts as a structural skeleton for your decision-making. Its entire purpose is to guide a workload toward measurable success, often in areas that conflict with each other.
Okay, so when you say measurable success, what are we actually measuring?
We're measuring very specific outcomes.
Mm-hmm.
So, is the workload resilient, available, and recoverable when things, inevitably go wrong?
Which they always do.
Always. Is the security posture sufficient for the data and the regulatory environment you're in?
Yeah.
Does it deliver a strong enough return on investment?
The ROI question always comes back to the money.
Of course. And does it enable responsible development and operations? And maybe most fundamentally, can it actually achieve its business purpose within the expected timeframes?
So if that's the complex set of goals, you've got resilience, security, cost efficiency, speed. What is the structure that forces you to consider all of them at the same time?
That's the guiding light, the intellectual core of the whole thing. It's the 5 pillars of architectural excellence.
The 5 pillars.
Precisely. These 5 pillars are the organizing principles, the foundational layer. We're talking about reliability, security, cost optimization, operational excellence, and performance efficiency.
Okay.
And every single piece of guidance, every checklist item, every design pattern is mapped directly back to one or more of those pillars.
All right.
They force you to take a comprehensive view.
Okay, let's unpack this then. Before we dive into the deep technical characteristics of those pillars, let's quickly define the playing field. Who is this guidance actually for, and why should they care? Let's jump straight into the who and why.
Okay, so the WF is hyper-focused on the workload.
The single application or service.
Exactly. Which means the primary audience is the team actively responsible for improving that workload and, crucially, addressing what we call cross-cutting concerns.
Cross-cutting concerns. Can you define that for us?
Sure. A cross-cutting concern is something like security or cost. It's not isolated. You can't just tackle security without impacting performance, and you can't optimize cost without potentially, impacting reliability. They cut across the entire application.
I see.
Therefore, the framework applies to anyone with decision-making authority within the scope of that specific workload, regardless of their title.
So you're talking about the architect setting the high-level plan.
Yep.
The developer making implementation choices in the code, the operator defining the monitoring strategy, and maybe most important, the business stakeholder who defines the acceptable limits for risk and cost.
Exactly. If you have the authority to change the structure of that application in the cloud, you are the audience. You're in the room where it happens.
And it doesn't matter how big your company is.
Absolutely not. The size of the organization is irrelevant. The WAF is highly beneficial whether you're a massive multinational enterprise, a fast-moving startup, or an independent software vendor building a product for others.
So it's not about enterprise maturity.
No, it's about moving toward optimal design quality for a single application or service. It's about craftsmanship at the workload level.
But let's be really clear about what this framework is not for, because I think a lot of people initially confuse it with broader cloud strategy.
That's a crucial distinction to make. The WAF is for the team, deep in the trenches, focused on one application's design.
Right.
It is not designed for improving an entire portfolio of workloads through centralized, organization-wide governance controls.
Okay, so if I'm a CIO trying to set policy for my entire IT department.
This isn't your starting point.
Yeah.
If your goal is that higher, broader strategic organizational governance, view things like financial reporting across departments
Yeah.
or mandatory security policies across 10 different application teams.
The documentation explicitly recommends looking toward the Cloud Adoption Framework, or CA instead.
3AF.
Yes. The CA focuses on organizational policies, readiness, and centralized governance. The WF is strictly about a specific application's architectural quality on Azure. And of course, if you aren't designing workloads on Azure, then this is just interesting reading but not essential guidance for you.
That distinction makes perfect sense.
Mhm.
I've heard it put this way. The way is the architectural blueprint for the house, while the CF is the city zoning regulation.
That is a perfect analogy. Exactly.
So, assuming we are that architect or developer facing down that blueprint, what does the framework promise to deliver? What are the practical goals that set us up for success?
The documentation outlines 4 clear objectives. The first goal is successful implementation through informed decisions. The framework's breadth and depth mean you aren't relying on tribal knowledge or guesswork.
Or just, the
Yeah.
way we've always done it.
Exactly. You are drawing on established, categorized, and continuously updated best practices, which instantly elevates the quality of your decisions. Second is confidence in success. This is an academic theory. The core insight here is that every tenet of the WAF is battle-tested.
That's so important.
It's backed by proven assessments seen across thousands of real-world workloads deployed on Azure. When you follow the WAF, you are using a structure validated by the operational reality of the platform.
The third goal, and you could argue this is the most important intellectual goal, is helping you understand trade-offs and risks.
This is where it gets tough.
It is. And this is where the framework separates itself from a simple checklist. It forces you to acknowledge that achieving a high score in one pillar, say, reliability, might require an intentional, documented choice against another pillar, like cost optimization.
Because redundancy costs more. Simple as that.
Simple as that. The framework highlights these accepted compromises and the specific short-term risks you inherit by making that choice. It formalizes the fact that a successful architecture is always a compromise, tailored to your budget and your business's tolerance for risk.
But if these trade-offs are so critical, how does the framework prevent a team from simply saying, cost optimization is our #1 priority, and then dangerously gutting reliability or security? Is there a built-in safety net against that kind of short-sightedness?
There is, and that safety net is found in the final goal. Optimize over time. The WAF is not a one-time audit. It's an iterative process.
It's a loop.
It's a continuous loop.
Yeah.
Use it to measure the maturity of your workload, and that evaluation is a moving score. So in your example, if you ruthlessly cut costs and you fail level 1 reliability standards, you know immediately what your highest priority deficiency is.
It shines a big spotlight on the problem.
Exactly. The design is only effective if you continuously revisit and refine it, ensuring that critical safety standards are met before you even begin to think about aggressive optimization.
We've established that success hinges on making tough, balanced choices and optimizing over time, but to make those choices consistently, you need a shared vocabulary and a foundational structure.
You do.
And that structure is, of course, the intellectual core of the entire guide. The 5 core pillars. Let's dive deep into what makes each of them essential. Okay, the 5 pillars. Again, they are reliability, security, cost optimization, operational excellence, and performance efficiency. The fundamental premise of the entire framework is that excellence is only achieved when design decisions are balanced across all 5, based specifically on your business requirements.
And to consume this guidance effectively, you need to understand the structure within each pillar. It's a standardized format, and it provides 5 key components that turn that philosophy into action.
Okay, what are they?
First, we have the design principles. These are the philosophical statements that articulate what good design looks like within that pillar. For example, a core principle of reliability is design for failure.
Okay, design for failure, not prevent failure.
Not prevent it. It defines the goal you're trying to achieve. Not preventing failure, but ensuring your system can survive it.
I see. What's the second component?
Second, the design review checklists and the associated recommendation guides. The checklists are your action items. The did you do X, Y, or Z? The guides are the deep technical strategy, explaining how specific Azure features like availability zones or automatic scaling help you implement that recommendation.
So the what and the how.
Precisely. Third are the cloud design patterns. These are the established, battle-tested solutions to common problems. Patterns like the cache-aside pattern for performance or the circuit breaker pattern for reliability are all mapped to specific pillars to show you where and why they provide benefit.
So you're not reinventing the wheel.
You shouldn't be. Fourth is the formal recognition of trade-offs and risks. This is the framework's acknowledgement of reality. If you choose a specific high-security encryption protocol, the WAF will point out the accepted compromise.
The trade-off.
The trade-off, which is that it might incur a slight performance hit. That's the risk. This transparency is vital for documented decision-making.
And the last one.
And finally, fifth, the maturity model. This is the phased approach we'll explore in more detail later. It gives you a roadmap, classifying recommendations so you can start with the essential items and gradually move up to mature, future-proof systems.
Okay, that structure makes sense. Now let's get into the specifics of the pillars themselves, starting with the one that often determines whether your business survives. Reliability.
Reliability is the ability of the system to recover from failures and continue to function correctly. This is defined by how well the workload can meet the service level objectives, or SLOs, that you define.
And the key mindset shift here is that failure is inevitable.
It is absolutely inevitable. You are designing for tolerance of failure, not the absence of failure. It's a huge mental shift for teams coming from a traditional on-premises world.
What's a core design principle here that illustrates that?
A great one is scale to meet demand. Reliability is often degraded by unexpected spikes in usage. The wave pushes you toward horizontal scaling, adding more instances rather than making one instance larger.
Scaling out instead of up.
Exactly, because horizontal scaling prevents one failure from taking down the entire system. If one of 20 web servers fails, you still have 19 running. If your one massive web server fails, you have 0.
That's clear.
Other key concepts here include things like self-healing mechanisms, implementing retries with backoff, and using those design patterns we mentioned like the circuit breaker to prevent cascading failures when a downstream dependency fails.
So we're not just building a system that works. We're building a system that breaks gracefully and fixes itself. That complexity, that feels like it leads us directly to the second pillar, security.
It does.
Security is often approached with a perimeter defense mindset, building a strong wall around the data center, a castle and moat.
The old way. But in the cloud, the way emphasizes a fundamental shift toward the principle of assume breach.
Assume you've already been hacked.
That's the core principle of zero trust architecture, which is heavily emphasized here. Zero trust means assuming that internal and external network traffic is equally hostile.
There are no trusted networks anymore.
None. Therefore, your primary security mechanisms must shift from network firewalls to identity and granular access control. You must use the principle of least privilege access, ensuring every component, whether it's a user or a service, only has the absolute minimum permissions necessary to function.
What are the key focus areas in this pillar?
The big ones are data protection, both in transit and at rest, and ensuring strong identity and access management. The documentation dives deep into concepts like conditional access, encryption key management services, and using robust secret management vaults to keep credentials out of your code.
That's a huge one.
It is. If you're not managing secrets properly, the WAF would say you haven't even started your security journey.
That all sounds expensive, which of course brings us to the third pillar, cost optimization. And this is where the tension really begins, because cost optimization is so often confused with just cutting costs.
Slashing budgets. Exactly. But the WAF reframes this. The goal isn't minimum cost. It's maximizing the return on investment, the ROI. That's the key. The core principle is manage costs proactively. You should also be asking, is this resource delivering value that is proportional to its cost?
How does that play out in practice?
Well, this is a nuanced pillar. It pushes architects toward techniques like right-sizing, making sure a service is neither over-provisioned, which is just wasting money, nor under-provisioned, which creates reliability risks.
The Goldilocks principle.
Kind of, yeah. It also mandates continuous monitoring of expenses using tools like Azure Cost Management. You can't manage what you can't measure.
What about pricing models?
It strongly favors consumption-based pricing models where possible and encourages commitment discounts, like purchasing reserved instances for stable, predictable workloads. But here's the interesting paradox.
Okay.
Sometimes investing more in automation, which falls under operational excellence, actually leads to better cost optimization in the long term. By reducing manual effort and eliminating human error. If a person has to manually deprovision a test environment, they might forget. If it's automated, it's gone, and the billing stops. The pillars constantly intersect.
That connection between automation and cost leads us perfectly to pillar number 4, operational excellence. This is where we ensure the system is manageable, sustainable, and reliable in its deployment and monitoring.
Operational excellence is defined by the quality of your operational procedures. The core principle here is, well, it's automate, automate, automate.
I'm sensing a theme.
It's a big one. The focus is on reducing cognitive load and eliminating manual tasks that are prone to error. If you deploy something once manually, you should assume it will be deployed differently the second time.
And that's how you get configuration drift and it works on my machine problems.
Precisely. This pillar mandates the use of infrastructure as code, or IAC, tools like Terraform or AR and Bicep, to ensure environments are reproducible. It emphasizes robust deployment practices, CI/CD pipelines, and rigorous monitoring through comprehensive observability solutions.
And observability is more than just logging, right?
Much more. You need logging, metrics, and tracing that not only tell you if the system is down, but why it's down, and crucially, what impact it's having on the user experience. You also need reliable, tested runbooks to handle incidents when they occur.
Okay, and that brings us to the final pillar, number 5, performance efficiency. For many end users, this is the only pillar they actually see, the speed and responsiveness of the application.
It's what they feel.
It is. So how does the WAVE define performance efficiency?
It's defined as the ability of a workload to scale to meet the demands placed on it. The central principle here is democratized data access, which essentially means making sure that the data your application needs is available quickly and efficiently without unnecessary latency.
What does that look like in terms of architecture?
It often translates into intelligent scaling strategies, again, primarily favoring horizontal scaling or scaling out over vertical scaling or scaling up.
We're back to...
We are. And it heavily emphasizes caching mechanisms. Caching is often the single most effective way to reduce database load and improve response times.
So it's about being smart, not just throwing bigger hardware at the problem.
Exactly. The WAF encourages architects to use high-performance services and ensure they conduct continuous load testing to understand the workload's true capacity limits before they are hit in production.
That's a big one, the before.
It's everything. If you haven't performed performance testing under realistic peak load scenarios, the WAF would categorize your design as immature in this area, regardless of how fast it performs during a single user test.
That detailed look at the pillars shows that the WAF provides the philosophical foundation and the essential building blocks. But as a listener, you might be thinking, that's a lot of philosophy. How do I turn those 5 pillars into technical steps on Azure?
A very fair question.
We need to look at the layered structure of the documentation itself.
The WAF documentation is highly structured, precisely to avoid that feeling of philosophical overwhelm. It adopts a very practical, layered approach. You start with the universal pillars, the foundation.
What we just covered.
Right, which then flow down to the workload layer, which is about application to specific classes of systems. And finally, you get down to the service guides, which are about individual component decisions.
And that order matters.
The structure is critical. If you don't have a comprehensive grasp of the 5 core pillars, the technical details in the subsequent layers lose all their context. For instance, you can't fully appreciate a database configuration recommendation in a service guide unless you understand the cost optimization and reliability principles that are driving it.
Okay, let's focus on that middle layer, the workload layer. This is the intermediary step that applies those broad principles to a specific context, say, a mission-critical web application versus a simple batch processing system.
That's exactly it.
The source explains that within the workload layer, architecture is segmented based on its utility into what are called design areas.
Right. And these design areas act as focal points tailored to that specific workload class.
Give me an example.
Think of it this way. A high-frequency trading application's workload guide will have design areas that heavily prioritize performance efficiency and reliability over, say, cost optimization.
Because speed and uptime are everything there.
Everything. Conversely, a data archival workload might have design areas centered on cost optimization and security compliance while accepting much lower performance targets. The workload defines the priorities.
And the structure of these guides is consistent.
Yes, very standardized. You start with the solution context, you review the specific design principles for that workload type, and then you dive deep into the design areas. These are the specific technical decision points, like choosing your network topology or your data management strategy, complete with recommendations tailored to that workload's priorities.
And what's excellent is that these workload guides integrate the final evaluation right there. They include an assessment component that helps you evaluate your production readiness based on the technical decisions you've made.
It's an immediate feedback loop.
Exactly. Now, below the workload layer, we find the specialized service guides. These are the ground-level instructions, vital for configuring individual Azure components correctly.
Right. These guides detail the key features and capabilities necessary to achieve architectural excellence when you're deploying specific resources, like Azure Cosmos DB or Azure Functions.
So they're not just a feature list.
No, they don't list every feature. They curate the information to emphasize how that service specifically helps you address those cross-cutting concerns we talked about and supports overall workload effectiveness. They give you the foundational configurations needed for optimal performance and security right out of the box.
And to help navigate the intersection of all these layers, the framework also provides something called design essentials.
Yes, and these are incredibly useful because they intentionally pull guidance across multiple pillars.
So they're thematic.
Exactly. A design essential might focus exclusively on logging and monitoring strategy. Well, that topic cuts across operational excellence, reliability, and even security. Instead of covering the entire journey of an application, these resources concentrate on one critical practice, offering prescriptive, targeted direction.
They sound like great shortcuts for teams trying to immediately shore up a weakness without having to review the full documentation stack.
That's what they're for.
And tying all these layered documents together, providing that measurable moving score we talked about earlier, is the formalized assessment component.
Yes, the Microsoft Azure Well-Architected Review. It's a powerful, free tool. It uses detailed questionnaires directly tied to the pillar checklists, asking you specific questions about your design choices against each of the 5 pillars.
And the power is in repetition.
The power is in running it iteratively. You track your score over time, identifying exactly which areas of your architecture need enhancement next. It is the engine of that continuous improvement model.
This layered, nested structure is necessary for covering the immense complexity of cloud architecture. But let's be honest, even knowing the structure, the sheer volume of information can still be overwhelming.
It can.
If you approach this framework purely academically, you hit analysis paralysis instantly. How do the experts suggest we approach learning and applying this without getting stuck? The documentation itself is pretty self-aware here. It actually acknowledges that reading all the guidance end-to-end is not practical.
Which is refreshing.
It is. So the WAF provides a specific, step-by-step learning path designed for pragmatic application.
And step 1 is mandatory and non-negotiable. Understand all of the design principles.
The philosophy comes first.
It has to. Before you write a single line of code or select a single Azure SKU, you must internalize the philosophy. Understanding good architecture is more important than knowing how to build it.
Can you say more on that?
You need to internalize the core principles: designing for failure, assuming breach, managing costs proactively, and so on for all 5 pillars. The guidance explicitly states these approaches are foundational. They aren't optional additions. They must inform your design strategy from the moment you begin.
Okay, that sets the mindset. Step 2 is where the pragmatism truly kicks in. Prioritize checklist items.
Yes, you absolutely cannot chase perfection across all 5 pillars simultaneously. It's impossible. You must prioritize based on your specific business factors.
And what drives that priority?
It could be business criticality. Is this a 247 financial system? Is it compliance needs? Are you handling protected health information? Or is it pure time to market?
So you have to know what matters most.
You do. If your application handles sensitive data, security items jump to the top of the list. If the acceptable downtime is 0, reliability dominates everything else. And this prioritization is fluid. You defer less relevant items and adjust your priorities as business factors change.
And this step prevents you from spending time, say, optimizing a security feature for a system that constantly crashes.
Exactly. Fix the fire first. And that leads directly to step 3, which is the most critical strategic exercise. Be ready to make important trade-offs.
This is the decision-making tool.
It is. You must recognize that prioritization will favor one pillar over others, and you must formalize the resulting compromises.
Let's use an analogy. You're building a specialized car.
Go.
If you prioritize performance efficiency, you're making a race car. You have to accept trade-offs in cost optimization. It's going to use expensive materials and maybe reliability because it requires constant maintenance.
Sure, a Formula One engine doesn't last for 100,000 miles.
Exactly. But if you prioritize cost optimization, you're building a reliable, cheap utility truck. You have to accept severe trade-offs in performance and probably security complexity.
That makes the tension so clear. Walk us through a few of those inherent contradictions the WAF specifically calls out.
Okay, let's start with the classic. Reliability versus cost optimization.
The big one. To increase reliability, you must introduce redundancy. Multiple services, multiple regions, automated failover. Every single piece of that redundancy adds direct cost.
There's no way around it.
None. The trade-off is simple. Higher reliability means higher cost, and optimizing for cost requires you to accept lower availability targets. You cannot maximize both.
Okay, what about security versus operational excellence?
That's a subtle but important one. Implementing new, complex security controls, say granular network segmentation across microservices, inherently increases operational complexity.
It's just more stuff to manage.
There's more stuff to manage, deploy, and monitor. It becomes harder, requiring more sophisticated infrastructure as code, more complex observability solutions. The trade-off is often less agility and a higher risk of deployment error when security is maximized.
That's fascinating. What about the eternal conflict? Performance efficiency versus cost optimization. We all want the fastest service for the lowest price.
We do. But physics and economics get in the way. High performance requires high-end computing tiers, low latency storage, and extensive caching, all of which are premium costs.
You pay for speed.
You pay for speed. When you prioritize maximum performance, you trade off cost. Conversely, optimizing for cost means accepting cheaper, often less performant components, or scaling down during off-peak hours, which requires an accepted compromise on peak speed.
And these conflicts aren't always between obvious pairs.
No, even seemingly unrelated pillars can conflict, like operational excellence versus reliability. You might prioritize operational excellence by automating 100% of your deployment, which minimizes human error.
Sounds great.
It does, but if that automation breaks, you now have a massive, systemic, single point of failure. The reliability principle of redundancy might suggest having a tested manual fallback, which flies directly against the operational excellence principle of automate everything. The art of design is finding that strategic balance.
Okay, so once we have the philosophy and we've calculated our trade-offs, the final steps are tactical. Step 4 is about matching workload scenarios. You go to that layered structure we discussed, find the workload guide that matches your prioritized scenario, and follow its technical recommendations across all the design areas.
It acts as a filter, narrowing the guidance to what is immediately relevant for you.
And step 5, select the appropriate Azure service and configure it correctly. This is where you use those detailed service guides. They support your final decision for each individual component, ensuring that even when you compromise, the underlying implementation is still grounded in the best possible practices for that specific resource.
The entire path ensures you are designing not for some theoretical perfection, but for the maximum suitability and maturity given your real-world constraints.
And that concept of measured resource-constrained maturity is formalized in the maturity model, which provides a tangible 5-level roadmap for growth. Let's dig into how that structured evolution works.
The maturity model is perhaps the most useful tool for teams suffering from that analysis paralysis we talked about. Its entire purpose is to facilitate a phased adoption of the WAF.
It breaks it into manageable chunks.
Exactly. It classifies recommendations into steps. It answers the question, what is essential to achieve now and what can wait until later?
And this applies universally, regardless of the company's scale.
Yes. Startups use the model to create foundational strategies they can implement over their first year. Large enterprises use it to audit and optimize their existing, maybe organically grown architectures, providing a common metric across disparate teams.
So it gives everyone a unified language for measuring progress.
It does. The model is categorized by the 5 pillars and divided into 5 distinct levels. Now, while the specific requirements differ significantly for each pillar, a Level 3 cost architecture looks very different from a Level 3 security architecture, the journey across the 5 levels shares common themes of increasing sophistication, automation, and business alignment.
Okay, let's start at the beginning. Level 1.
Level 1. Establish a solid foundation on Azure. The focus here is on the low-hanging fruit and utilizing what Azure provides natively.
So, using the platform as intended.
Right. For example, in reliability, this means deploying using managed services that have built-in fault tolerance, utilizing Azure's platform as a service offerings instead of raw virtual machines, and implementing standard geo-redundancy defaults.
And for security?
For security, it means using native network security groups, NSGs, and basic identity management via Azure Active Directory. You're essentially using the cloud platform responsibly, not trying to reinvent core infrastructure.
Okay, so level 1 is proving you can use the basics correctly. Then you move to level 2. Build workload assets. This is where the team starts taking ownership of the specific, unique complexity of their own application.
That's the key shift. The focus moves to components directly owned by the workload team. This means implementing robust CI/CD pipelines, formalizing infrastructure as code for all deployment assets, not just the core services, and building custom monitoring logic specific to your application's business metrics. For operational excellence, this is where you write your first set of reliable runbooks and ensure all your application code is integrated with the centralized logging solution.
Okay, that makes sense. Then we hit level 3, be production ready.
And this is the massive pivot point. This is the gatekeeper for launching new workloads. To reach level 3, the complexity of the trade-offs must be explicitly discussed and signed off on by business stakeholders.
The business has to be in the room.
They have to be. For reliability, this means implementing automated disaster recovery tests and ensuring key components can fail over with minimal intervention. For cost, it means formalizing cost, governance setting specific budgets, and implementing alerts tied directly to those budgets.
What about testing?
This level often includes preliminary chaos testing, intentionally injecting simple failures to validate the automated responses. You are proving that the design works under stress and that the business understands the risks you've accepted.
Once you are live, the mindset shifts. You enter level 4, learn from production. The focus is no longer on building, but on maintaining stability, managing change, and reacting to real-world performance.
Exactly. This involves sophisticated observability. It means implementing advanced telemetry that tracks not just technical metrics, but the user's journey and its performance.
You're measuring user experience, not just CPU.
Precisely. For reliability, this is where you start using complex chaos engineering techniques, maybe performing game days where teams simulate major regional outages. For operational excellence, the focus is on maintaining a stable environment, accommodating new requirements based on production learnings, and ensuring your documentation reflects reality. You are constantly refining based on hard data.
And the final stage is level 5, future-proof with agility. This sounds aspirational.
It is the aspirational level, marked by proactive readiness for external change. You're not just stable, you're highly agile and automated.
What does that look like?
This level involves striving for radical automation, using predictive analytics, maybe AI or MLOps, to anticipate failures before they occur. For performance, it might mean constantly optimizing the code and infrastructure for the newest chip architectures or service tiers.
And security.
For security, it involves integrating threat modeling directly into every stage of the CI/CD pipeline. The team is adept at rapid change, positioning the workload to handle new market conditions or evolving regulatory concerns immediately.
That detailed roadmap is fantastic, but the danger remains. The temptation to chase level 5 too fast.
Yes.
This is why the source provides specific guardrails against that. You need to apply constraints when using this model.
The first crucial consideration is to evaluate the value of practices. The timing is everything. Implementing a sophisticated practice like level 5 automated cost optimization too early may yield almost zero benefit because the workload itself isn't stable enough yet.
It's an intellectual curiosity, not an operational need.
Exactly. Conversely, delaying essential practices like basic security controls increases cost, complexity, and technical debt because you later have to retrofit those controls into a live moving system. You must prioritize practices that deliver immediate, meaningful, and foundational benefits.
That concept connects directly to the second point. Evaluate the cost of practices. And again, cost is not just money.
No, it includes effort and complexity. And the WAF explicitly warns us about the highest cost factor. Implementation expenses skyrocket if practices are adopted before the workload team is ready.
So team readiness is a cost factor.
A huge one. If the team hasn't mastered infrastructure as code, which is a level 2 concern, forcing them to implement chaos testing, a level 3 or 4 practice, is expensive and counterproductive.
And the framework also makes a subtle point about discontinuing practices?
Yes, you must be prepared to define exit criteria. Some practices, which were valuable at level 3 for establishing stability, might become too expensive or complex to operate at level 5, where the benefit they provide is superseded by radical automation. You must continuously assess whether the operational cost of a practice still justifies its value.
The third guardrail is being deliberate when choosing your implementation sequence.
Right. Since practices are interdependent, you need to map out the prerequisites. If a robust monitoring solution under operational excellence is a prerequisite for effective cost management alerts under cost optimization, you have to implement monitoring first.
Build the foundation before the walls.
Always. Prioritize the building blocks that reduce the cost and complexity of the steps that follow, and consider the time to outcomes.
And finally, the fourth consideration. Be realistic about your capacity.
This is about being honest with yourself. Organizational capacity is finite. As operational costs increase, maintaining that stable, complex Level 4 environment, the team's capacity to implement new Level 5 practices naturally declines.
It's the concept of opportunity cost.
Exactly. Choosing to spend development cycles on achieving a niche security certification now means deferring that critical performance improvement. The maturity model must be viewed through the lens of realistic resource allocation.
This is essentially advising us to use the maturity model not as some kind of high-score competition to get to level 5, but as a realistic, constrained roadmap for continuous, meaningful improvement that respects the team's capacity and budget. #outro. Okay, let's bring this deep dive into the Azure Well-Architected Framework home. If you remember nothing else, remember this structure. The WAF is a balanced 5-pillar framework: reliability, security, cost, operational excellence, and performance efficiency.
And it's structured logically into layers, pillars, workloads, and service guides, designed to make the vast amount of technical guidance digestible.
And success is found by understanding and documenting your intentional trade-offs.
Recognizing that maximizing everything is just impossible.
And most importantly, it's built for sustainable growth, guiding you through an iterative, achievable journey via the clear 5-level maturity model, moving you from initial foundational steps to an agile, future-proof solution.
What stands out to me here at the end of the day is how the framework formalizes the inherent tension in engineering. You can't maximize security, performance, and cost simultaneously. It's just not possible. Success is found in deliberate, documented trade-offs based entirely on your specific business needs and, crucially, your team's operational capacity. The WA provides the language and the structure to have those honest, critical conversations.
That capacity piece is the real challenge, isn't it? The source explicitly mentions that higher implementation costs arise if practices are adopted too early before the workload team is ready. So what does this all mean for measuring team readiness? And how should a team use the maturity model less as an architecture checklist and more as a readiness metric for their operational capacity?
That is the question.
Is your team level 3 ready to sustain a level 4 system? That's your assignment. That's it for this deep dive into the Azure Well-Architected Framework. We hope you feel equipped to navigate those layers and start making those tough but informed trade-off decisions. Until next time, keep digging.